Hello, it's Miss Beatty here, and I am going to introduce to you equivalent fractions. Okay, so we are going to find fractions that are equal to each other. They might look different and they might be written different, but they are actually equal to each other. So this is new to a lot of you, if not all of you. So it's important to watch this video. Okay, you can pause it at any time if you're not too sure. You can rewind it, but it will certainly help with the activities. Okay, mild and spicy. I've not added a hot activity again because it's a new concept and I don't want to make it too difficult for you, okay? So even just looking at this page here, you can see I've got a half, I've got 2/4, I've got 3/6 and 4/8. Now, they all look very different, and actually when you look at 4/8, it looks so much more than 3/6. It looks so much more than a half. But actually all these fractions are the same value, okay? They are all equal to a half because 2/4, 2 goes into itself once, 2 goes into 2 twice, which is the same as saying a half. 3 goes into itself once, 3 goes into 6 twice, so it's the same as saying a half. And you'll notice, look, here is a half, it's straight down the middle is a half, straight down the middle here is a half. Straight down the middle here is a half. 4/8, 4 goes into itself once, 4 goes into 8 twice, so it's a half again. And you can see that from our shapes that they all are the same value. Okay, here is another sort of example. Okay, we know that equivalent fractions have different numerators. So if you see in this example here, we just looked at the same one, okay, but you can see the numerator is different in all of these fractions and the denominator is also different. So they all look different, like I said, but their fractional value is the same, okay? So that's important to remember. So example number 1, okay? I'm just going to move myself over here. Example number 1. This circle has been divided into 3 equal parts. 3 equal parts. What fraction of the circle is coloured red? Okay, so to find that out, we know, well, there's 3 parts in total, so I know that my denominator, okay, my number on the bottom of the fraction is going to be 3 because we've got 3 parts in total. How many parts are shaded in red? Well, we know the answer is going to be 1, 2, so 2/3, okay? 2/3 of the shape is coloured red. Okay. This example says, but the same circle has now been divided into 6 equal parts. Okay. What fraction of the circle is coloured red now? So again, we need to put the total number of parts on the bottom to become our denominator. 1, 2, 3, 4, 5, 6. Right, there's 6 total parts that are equal to each other. And 1, 2, 3, there's 4 parts shaded in red. So I know that 4/6, okay, 4/6 of the fraction is shaded red, okay. And if I look carefully, okay, if I look carefully at these two fractions, they are actually the same value because 2/3 here, okay. If I look here, how many times does 2 go into 4? Well, the answer would be 2, okay? 2 goes into itself 4 twice. How many times does 2 go into 6? 3, okay? So it's the same as 2/3, okay? 2/3. 4 we know goes into itself, but it doesn't go into 6. So we can't use 4 to divide into the fraction. We can't use 3 to divide into the fraction because it doesn't go into 4, but we know that 2 does go into both of our numbers. 2 goes into 4 twice, 2 goes into 6 3 times. So 2/3, okay, is our answer. 4/6 is equivalent to 2/3. Okay, I hope that makes sense. We'll try one more example. Well, a couple more actually. Write down, okay, the two fractions that are equivalent to each other. Again, they look different, but they are equivalent. They are still equal value to each other, even though they look slightly different, okay? Right, our denominator, our number on the bottom for this is going to be the total number of parts. We've got 1, 2, 3, 4, 5. We've got 6 parts in total. And what color is shaded in? What fraction of the shape is colored in? The answer for this one would be 2. So 2/6 of the circle, or half the circle, sorry, the semicircle is shaded in red. So we've got 2/6 of the semicircle are red. What about our semicircle here? Well, we know it's cut into 3 parts in total. 1, 2, 3. and 1/3, one part of it is colored in red. So 1/3 of our semicircle is colored in red. Now, these fractions are equal to each other. They are equivalent because if you look at 2/6, right, we need to use our 2 times table because actually 2 can go into itself. How many times? 2 goes into 2 once. How many times does 2 go into 6? 2, 4, 6. Okay, so 2/6 is actually the same as 1/3. We don't need to change this because it is in its simplest form. It cannot change anymore, whereas we know that this fraction can change. It can become less in terms of our numerator and our denominator because 2 can divide into 2, 2 can divide into 6. So 2/6 is equivalent to 1/3, okay? What about this example? Write down the fractions that are equivalent to each other, okay? So let's first of all, let's work out the fraction of each shape, okay? So I'll just put a line here, the fraction of each shape. So this fraction here, we know in total there's 2 pieces. One part is shaded in blue, so it becomes a half, okay? Half of the shape is shaded in. What about here? There's 1, 2, 3, 4, 5. There's 6 pieces in total. And 1, 2, 3. 3 parts are shaded in blue. So 3/6 of that shape is blue. What about this example here? We've got 1, 2, 3, 4, 5. We've got 5 pieces in total. Okay, 5 pieces in total. And 1, 2, 3. 3 pieces are shaded in purple. So 3/5 of that shape are purple. 1, 2, 3, there's 3 parts in total. Okay, and 1 part is shaded in blue. Okay, so 1/3 of the shape is blue. Now we need to work out, okay, what fractions are equivalent to each other? Well, 1/3 is not equivalent to a half, so that doesn't work. 3/5, that doesn't seem like it's equivalent to 3/6 or 1/3. Okay, so we'll leave that one out. What about 3/6? That seems to be equivalent to one of our fractions. So let's have a little look here. 3 divides into itself once. So if we do that, and we'll write it up here. How many times does 3 go into 6? 3 goes into 6 2 times, because if we do our 3 times table, 3/6, we know it's 2. So we know that this fraction here is equivalent to this fraction here. 3/6 is the same as a half. Okay, and you can see that it is a half because look, this line goes straight down the middle. We've got half here, and that's a half. Okay, 3/5 and 1/3 are not equivalent to each other. So there we go. Okay, and we'll do one more example. When you're looking at your activity sheets, there's also a task that says you can find an equivalent fraction simply by multiplying the numerator, the number on the top of the fraction, and the denominator by the same number. Okay, so for example, I've got a half here. I multiply the top number by 3, the bottom number by 3, I'm going to get a new fraction that's also equal to a half. 3 times 1 is 3. So we write 3 on the top as our numerator, and 2 times 3 we know is 6. And if I was to divide, 3 by itself becomes 1. 3 into 6 is 2. I know that 3/6 is the same as a half. Okay? What about this one here, a quarter? A quarter can become 1 times 3 is 3. 4 times 3 is 12. A quarter can be the same as 3/12. And we know that 3/12 is definitely a quarter because 3 divided by itself is 1. Okay, and how many 3's go into 12? 3, 6, 9, 12, 4. So we know 3/12 are equivalent to a quarter. Okay, what about a fifth? What can a fifth be equivalent to? Let's find out. Okay, 1 times 5 is 5, so our numerator now becomes 5. And our denominator, 5 times 5 is 25. And how do I know that's a fifth? Just want to double check that. Well, I know that 5 divided by 1, or how many 5's go into 5 is 1. 5 times 1 is 5, so 1 goes on the top, okay? And how many times does 5 go into 25? 5, 10, 15, 20, 25 goes into 25 5 times. So 5/25 are the 25ths even. 5/25 are the same as a fifth. Okay, so those are, or that is equivalent fractions, okay? They might look different. The numerator and the denominator are different numbers, but they are the same value, okay? They can be divided into by a number, okay? So for example, I'll show you one more little example. If I had 2 6, we've looked at that already, 2 6, we know 2 goes into itself once. How many times does 2 go into 6? 3. So 2 6 is a third. What about, let me have a wee think, about 10 20ths? 10 20ths. What can that be the same as? Well, I know that 10 goes into itself and 10 also goes into 20. So 10 goes into itself once and 10 goes into 20 twice. So 10 20ths is equivalent to a half. 2 6 is equivalent to a third. We'll try one more. What about 6 24ths? Okay, now this is obviously getting into bigger numbers. We have to use our trickier times tables, okay, our more difficult times table. So I know that 6 goes into itself and 6 also goes into 24. They're both in the same times table. So 6 goes into itself once. How many times does 6 go into 24? 6, 12, 18, 24. It goes into 24 4 times. So 6 24ths are the same as a quarter. So those are equivalent fractions. Okay? So I hope that makes sense. It's using your multiplication skills and your division skills. So try your best. Like I said, pause the video if you need to at any time. Ask questions if you're not sure, and remember to take pictures of your finished piece of work and upload into your files, or post it just on the main chat in Teams or email it to me. Okay, good luck. Try and be as independent as you can. And eventually, with a bit more practice, you will become even better at this. And we'll focus on equivalent fractions tomorrow as well. Okay, great.